Assalamualaikum and hello there. I am Amir Zakariah, the leader of Team Full House, and the purpose of me making this video is to talk about the applications of differentiation. So, assuming that you're either Dr. Rizaldi himself, if that's the case, hi doctor, or you're just a student watching this video to increase your understanding in the fields of applications of differentiation, I hope you enjoy it. So, straight to business. What is differentiation? Because to understand application of differentiation, you must understand what is differentiation. So differentiation is a method in finding a derivative of a function at any given point. Now, in calculus specifically, the derivative of a function is a measurement of how a function changes when the input changes. Suppose a quantity may be y, a function of another quantity x, so we have y equals fx. When there's a change in x, y also changes. For example, maybe we input x as 1, so y equals fx now becomes y equals f1. So y's value will not be the same as x has become 1. Now, in order to find this rate of change at any value of x, we must find the dy dx, the derivative, at that particular x. In a y versus x graph, dy dx gives the value of the slope of the tangent drawn at point x. In applications of differentiation, there are a few problems related to this chapter. This includes related rates, analysis of functions, and maximum and minimum values. So, let's get started with related rates. Water is flowing at a rate of 5 meter cubed per minute into a tank. The tank is a cone with an altitude of 20 meters, base radius of 10 meters, and the vertex is pointed down. How fast is the water rising at a time it is 8 meters deep? So from the question, we can extract a few information about the shape which is going to be produced. In this case is a cone. So, the given height of the cone is 20 meters. As mentioned that the altitude is 20 meters. The current height of the water is 8 meters. The radius is 10 meters. And the rate of the water increasing is 5. Now, the question wants to find the speed of the water rising when it reaches 8 meters. And the speed is dh dt. And to get dh dt, you have to find this formula. dv dt equals dv over dh multiplied by dh over dt. So, in order to find the speed of the water, you have to find the volume of water using the volume of cone, 1 over 3 pi multiplied by r squared multiplied by h. So, in order to find the values, you have to plug in the given ones, but we don't have a given value for r. And if we don't replace this with something, it will be impossible to solve. So in this case, I used the ratio method. Since the height of the cone is 20 and the radius is 10, so it will technically look like a triangle. So what I did was 20 over 10 is equivalent to h over r, which 20 is the height and 10 is the radius. So 20r equals 10h, and r is now 1 over 2 over h. So, I substituted the value of r with 1 over 2h, and the product of this operation is pi h cubed over 12. So, dv dh equals the derivative of pi h cubed over 12. And all I did was I just plugged in the values into this formula. dv dt equals dv dh multiplied by dh dt. So after plugging in, I replace everything with the given values. 5 equals the derivative of pi h cubed over 12, which in this case is pi over 12 multiplied to 3h squared, and then times dh dt. So after that, we just plug in all of the given values. We have the h, which is 8. So pi over 12 times 3 times 8 squared. So we will get the final answer is dh dt equals 5 over 16 pi. And since it wants the speed, so dh dt is now 0.099 meters per minute.
Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. My name is Sani bin Mahazir, and for my part I will be explaining more about analysis of function 1. As far as I'm concerned, what I learned in this topic is first critical point, and second is increasing and decreasing function, third is concavity and inflection point. So if you look at the example, fx equals to x squared minus 2x minus 3. So first we have to find the critical point, and which is let's put it over here, fx equals to x squared, and what's the question again, x squared minus 2x minus 3. Okay, first how to find the critical point is we have to find the derivative of function fx. So what we get is 2 times 1 is 2, and 2 minus 1 is 1, so 2x minus 1 times 2 is 1 times negative 2 is negative 2, and 1 minus 1 is 0, so it becomes 1. And this is what we get. And 3, we don't have anything. So this is the derivative of x squared minus 2x minus 3. Okay, and then we make it equals to 0. Then we move negative 2 to the other side, and we get 2x equals to 2. And then we move this number 2 over here. So it becomes, let x become single. X equals to 2 over 2 equals to 1. So 1 is the critical point for x squared minus 2x minus 3. Critical point CP. Okay, next is to find the increasing and decreasing function. After we find the critical point, we make a table, which is f prime, wait, I forgot to put this one, f prime x. Yeah, okay, so f prime x, and down here we put fx, and the critical point is 1, so we put 1 over here. This is 1 because it's the critical point. Now we choose the number what is below 1, so let's make it easier, we choose 0, right? And then we substitute 0 into the equation, we get negative, because 0 square is 0, 0 times 2 is 0, so we get negative 3, so we just put the negative, and then we choose a number that is above 1. Let's just choose 3. We substitute 3 into the equation. 3 squared is 9. 9 minus 2 times 3 is 6. 9 minus 6 is 3. 3 times 3 minus 3 is, we get a positive number. Oh, we got 0, so means it's constant. Constant. and if it's negative, mean this one x is decreasing. Okay, after that we have to find the concavity and inflection point, which is quite easy. After we get the derivative of x squared minus 2x minus 3 is 2x minus 2, we have to make another f prime, which means f prime prime. Yes, so it becomes like this: f prime prime x equals to, so 1 times 2 is 2, and 1 minus 1 is 0, so we get 2. That's it. Since it's a positive number, uh, fx is concave up. Is this is how you do this is how you write the answer for concavity. Concave up at negative infinity infinity. That's all from me. Remember, never be afraid to do math, but always let math be afraid to do you. Moving on to Zafran.
Hello and Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Zafran Hanis bin Zainizam, going to explain to you the analysis of function 2. It consists of asymptotes and sketching graph for even and odd polynomial function. Okay, for asymptotes, there are two types of asymptotes, which is vertical and horizontal. For the vertical asymptotes, it is a vertical line which correspond to the zeros of the denominator of a rational function. Okay, let me explain to you more by doing an example. Okay, let's say that we have this function. So how are we going to do the how are we going to find the asymptotes for the for this rational function? So first, since you are talking about vertical asymptotes, so the way of doing it to find it is by making by this denominator is equal to 0. Okay, now we only have to solve it. X plus 2 is equal to 0, and hence x is equal to negative 2. So this is our vertical asymptotes. So in the graph, you will see it like this. Let me show you. So this is vertical asymptotes. This is x line. Okay. Okay. Next, we are going to find the horizontal asymptotes. Okay, as you can see here, we're going to use this function, this rational function, as an example. Okay. There's a formula for horizontal asymptotes. Let's say I write like this, which is y is equal to limit x approaching to plus minus infinity. Okay, fx. So this is the this is the formula that we are going to use when we are solving or finding the horizontal asymptotes. So we are using this example. So since y is equal to limit x approaching, we choose positive first, positive infinity, x minus 1 over x plus 2. So the next step is, since x is approaching the infinity, positive infinity, all of this function, rational function, will be divided by x. What I mean is, this numerator will be divided by x, this denominator also will be divided by x. So we will write it back, limit x approaching infinity, x minus 1 divided by x over, in bracket, x plus 2 divided by x. Okay, continue it here. For the next step, limit x approaching to plus infinity. Okay, x divided by x will become 1 minus 1 over 1 divided by x will become 1 over x divided by, again, x divided by x will become 1 minus 2 divided by x will plus 2 divided by x will become 2 over x. Okay, this okay, this number and this number will become 0. So the next step is, what I'm going to write is limit x approaching to positive infinity, 1 over 1 is equal to 1. So this is the answer for finding the horizontal asymptotes. These steps is just the same as for the negative infinity. So you don't have to worry about that. Okay, now I'm going to explain to you the sketching graph of, for even and odd polynomial function. Okay, when we are going to sketch the graph for even polynomial function, there are 5 steps on when we want to draw or sketch the graph. Okay, let's take a look at an example. Okay, so this is the example, and for us to draw the even polynomial functions. For the first step, it says that we have to find the y-intercepts first. So how? By substitute 0 into x. So the y-intercept will get 3. For the next step, we are going to find the x-intercept. If we want to find x-intercept, we must substitute 0 into y. So we just have to we just have to factorize it. So we will get x minus 1 and x minus 3 equal to 0. Okay, now we will get the points of x-intercepts, which is x is equal to 1 and x is equal to 3. Okay, for the third step, it says that we need to find interval for the graph, either it is increasing or decreasing. So it is just how like Sani explained to us. So from this function, we have to differentiate it. Okay, so this is the function. We'll make it equal to 0, and The answer should be like this. Okay, this now what we get here is the critical point. We must make a table which consists of f prime x and fx. Okay, so this is number 2 here, our critical points. And now on this side we must choose one number lower than number 2. So let's say I take 0 since it's the easiest. So when we substitute this 0 into the function of f prime x, we will get negative number, which is negative 4, since 2 times 0 minus 4 is equal to negative 4. So we will get here negative. When it is negative, the graph for this function is decreasing. Okay, so on this side we have to find, or we have to use a number that is higher than 2. Let's say I will take 3. Okay, when this 3 must be substituted into this function to determine whether this is plus or minus, this plus is positive or negative. So since when we substitute this 3 into x, we will get positive number, and the graph will for the function will be increasing. Okay, for the next step, we need to find the concavity and inflection points. So from this function, which is we have differentiate earlier, we need to differentiate it again in order for us to find the concavity. So okay, what we're going to do now, from this function that we have differentiate, we differentiate again f double prime x. So this is the concavity of the function. Okay, since this is our concavity, in this function there are no inflection points. Okay, now I will explain for the last steps, which is to find the relative extrema. Okay, as you can see here, since there are changes in signs here, so the critical point is 2. So we have to substitute this critical point into this function. So it will become like this: f prime 2 is equal to 2. Hence, this is the relative extrema. Okay, for the last thing that I will explain is to sketch the graph for odd polynomial function. So for sketching the odd polynomial function, it also has 5 steps, which is the same as before. So these steps is just the same as sketching for even polynomial function. So let us take a look at the example. So right now we have this function which is fx is equal to x cubed minus 3x plus 2. For the first step, we're going to find y-intercept. Okay, it's easy. You just substitute 0 into x. So this is y-intercept. Okay, now we're going to find the x-intercept. So how are we going to do it? By making y is equal to 0. So it will become 0 is equal to x cubed minus 3x plus 2. So you can use this. You can use the calculator to get the roots. The coordinate for the x-intercept is 1, 0, and negative to 0. Okay, now we're going to find the interval of the graph, either it's increasing or decreasing, right? So that's for the third steps. Okay, what I'm going to do now, we have to differentiate this function. So f prime x is equal to 3x squared minus 3. So now before equal to 0, and then the answer should be like this. Okay, now as you can see here, we have even power, so it will become plus minus 1. So now we have two critical points, which is 1 and negative 1 something. So for when x is equal to 1, y will become 0. So when negative 1 is x is equal to negative 1, we will use this function to get the y, so it will become 4 here. So these are the two critical points. Make a table. So this is our 1 and for negative 1, and here we will put 1. Okay, so we choose a number lesser than negative 1, so it will become negative 2. So when negative 2 is substituted into the function here, which is positive over here, therefore the function is increasing over here. Okay, so now we choose a number greater than 0, greater than negative 1, which is I'll choose 0. So 0 substitute in here, we'll get negative 5, so it will become negative here, so it's decreasing. Lastly, we will choose for this, I will choose 2. So when 2 is substitute in here, we'll get positive here, and it is increasing. So now we're going to find the concavity for this graph. So we need to differentiate this function again. This is concavity for the function. So we need to make equal to 0, then x is equal to 0. So we'll make a number line. So we choose a number less than 0, which is negative 1. So in here we're negative 1, the number will become negative 6, so it's negative, so it will be concave down. And for this part, which is a number higher than 0, I'll choose 1, so it will become positive, so it's concave up. So as you can see here, for this function, it has an inflection point, which is x equal to 0. So for the last step is we're going to find the relative extrema according to the second derivative test. We're going to use the critical point, which is x is equal to plus 1 and minus 1. So when f is equal to 1, we need to substitute this into the f double prime x. So you'll get 6, which is the minimum point since it is larger than 0. So for another one is negative 1. Here we substitute, we will get negative 6, which is the maximum point since it's larger than 0. I mean is lower than 0. Okay, so now from the points that we got, let's plot the graph. Okay, so now since the concavity for before 0 is going is maximum or is going up, so the graph should be like this, going up, and then you come here. So this is the inflection point, and then where the change of graph occur, change of the sign. So since after 0 will become positive, I mean after -1 here, positive, so it will become concave up. Okay, then we'll go here and it will go up because of go for the one at after 0, it will increase, so you will get 1 here. You will go up, increasing. So that's all from me. Thank you very much. Hope you understand, because I myself hard to explain. So thank you again.